Okay, so in this video, we're going to be talking about the rules of differentiation, right? But before that, I'd just like to, on the side, explain to you a few trigonometric differentiation rules that we ought to know right now. So the differential of sine x gives us cos x. These are just some random facts, nothing to be worried about at this point. So if you get an understanding of why this is, then it's going to be helpful later on. The derivative of cos x is going to give us minus sine x, right? That the minus is the distinguishing feature of this trigonometric function, and the differential of tan x gives us secant squared x. So at this point, this knowledge about trigonometric functions is sufficient. If we basically need to talk about these, we do so in a lot more detail. So the first rule that I'd like to talk about is the sum rule, but it's not technically a rule, it's more like common sense. If we're trying to take the differential of two functions, f of x plus g of x, it could be y as well, but it has to be a function of x for this to work, we'd simply get d by dx of f of x plus d by dx of g of x, and this simply results in f dash x plus g dash x. And this could be extended to, by the way, n functions, or even more than that, infinitely many functions. And if you try to take the differential of them by separating them out, it's going to be equal to the summation of the individual differentials. So basically, if I have 2x plus x squared, I'm going to differentiate that independently and do the same for that, and then add those together, right? So the differential of this is 2, the differential of that is 2x. So it's giving me the same thing, right? So this is an important rule. The other important rule that you guys should know is known as the product rule. Now this comes forth when you have two different functions multiplying with each other. They need not be like different, but the idea is that they have something special about them that makes this product rule work. So if I have a function over here, g of x, let's describe it in general terms first before moving on to examples. And h of x is another function of x, right? So if I were to find f dash of x, that would simply be g of x multiplied by h dash x plus h of x multiplied by g dash x. So basically you're alternating. First you're finding the differential of this, multiplying that by that, h of x, but you keep it constant, right? You don't really change anything over here. You don't differentiate both of them together. You differentiate this first, multiply it by that, and then add this multiplied by the differential of that. So you're basically having the best of both worlds over here. A different way to think about it, Reza. If you have an example, it would probably be something like x times sine x. If you were to try to evaluate this, you'd use this rule exactly. Let's try that for a second. You have x over here times sine x, right? So what's the differential of sine x? According to this rule over here, you can say we get cosine x, right? But now we're done with differentiating sine x, so now we're going to move on to x. So we're going to add a plus over here, we're going to differentiate x, we're going to get a 1, and leave the sine x as it is, because that's the rule. You differentiate one of them every time and leave the other one as it is. So the solution to this would be x cosine of x plus sine of x. Simple, right? I know. You can extend this to anything, and you could apply this for similar functions as well. For example, x to the power 4, what do we expect its differential to be? Well, if we differentiate this, we're going to get 4x to the power 3, right? But let's think of this as two different functions, x squared and x squared. If you use the logic over here, what do we get? Well, we're going to try to differentiate x squared first and leave x squared as the same. We get 2x times x squared, and then we do that for the other x squared, we get x squared times 2x. So what are we getting over here? We're getting 2x cubed plus 2x cubed. That's basically equal to 4x cubed. So it's the exact same thing. We're getting 4x cubed as we expected to obtain it, right? Another very important rule is slightly different than the others, right? It's an extension of the product rule, but slightly difficult to understand. So basically, what are we going to get over here? This rule is known as the quotient rule. The function f of x is equal to g of x divided by h of x, right? And quotient is basically when you try to divide two things together, right? So what if I want to find f dash of x? You know, the idea is that basically what you're doing is you're going to rewrite this as h x times g dash x minus, we know what's coming in s, right? We're going to keep the other thing constant. G of x times h dash x. But the thing that's kind of different over here is that you have to divide this entire thing by h x whole squared. So this is the different thing over here that we're going to have to do. Some people like to use the u and v notation. So if we have u being divided by v, that's a weird v. Let me just rewrite that out. So basically what people prefer to do is express this as u divided by v, like you do in integration by parts as well. So if we have this, the product rule, or in this case the quotient rule, is going to be expressed as v times u dash minus u times v dash divided by v squared. So that's another way to think about it. It's the exact same, but this function analogy is simpler to understand, right? So that's one way to go about it. Let's try to do this for an example. What if we have sine x divided by x? We want to find the differential of this. Well, we're going to try to use this through, right? So we know that we have to write the denominator as it is and differentiate the numerator first. Now this is an important rule, that you have to differentiate the numerator first. And if you don't, then the negative sign is going to mess everything up and you're going to have to read the process. You're going to get a completely different answer sometimes. So it's better to just follow this rule. So we differentiate sine x and we get cosine of x. We put a minus in the middle and then we keep sine x constant, right? And differentiate it by x, which is 1. But we divide this entire thing by x squared, which is basically v squared, or h of x squared. And what we get is basically x cos x minus sine x divided by x squared. And needless to say, if you're having trouble with this, understanding the trigonometric differentials, it shouldn't be a problem, because I've written that above, and these are things that you should kind of have like on your fingertips by now. Other than that, it's a very simple concept. It gets complicated sometimes if you get different functions, large functions, but if you use the fundamentals that I'm teaching to you guys in these videos, I think you guys will have a very good grip on this. So hopefully in the next video we're going to be talking about another important rule known as the chain rule, and then we're going to be moving on to much more advanced techniques. See you guys in the next video.